were, I think, the 1st and the 2nd of April. Now it's been pushed back, so the last day of this quarter is April 2nd. So in 3 weeks and 1 day. Then next quarter would start after spring break at that point. As far as late work goes, just because we're talking about end of the quarter where things got moved, originally I think I had March 29th as like the final due date for all this stuff. I'm going to push that back to just the end of the year. So for first and third quarter material, um, as long as you get it to me before the school year is over, I'll put it in for you. So just kind of an update on that. I'll go through and change that on the actual website so that it doesn't like lock you out of stuff once we get to that date. But that'll be for all assignments. Okay, so we are looking at graphing sine and cosine functions here. They say plot all the points corresponding to the x-intercepts, minima, and maxima within one cycle. So for our sine function, the way that sine always looks, it goes through the origin, kind of moving from the bottom left up to the top right, goes up and it hits a maximum of 1 before coming down to a minimum of -1. Um, before coming down to -1 and then rising back up back to 0 for a final time, completing that full cycle of going up and then down, or sorry, up and then down and then back to where you start. You complete that full cycle in 2 pi radians of angle measurement, so or 6.28, right? Um, so that is kind of basically the picture we want to draw out. Now, the only difference is that ours has this amplitude of 1/2. So we're not going to go all the way up to 1. We're just going to go up to 1/2. I usually fill in the first 3 points, kind of the horizontal ones. So we have 0 pi, 2 pi, and we are only going up to 1/2 and going down to 1/2 in between. We can then plot that and should be good to go. Cosine looks very similar to sine. Only difference is that it starts at 1, heads down to -1, comes back to 1. So it only has 2 x-intercepts within its cycle. Okay, so same thing here. We would just do the same. I would usually plot like the first point. Now in this case, we have no amplitude out front. So we are just going to be up at 1. And then maybe if I would just plot kind of what a normal cosine one would look like, we would normally end at 2 pi. And we would cycle down in between. Okay, so that would be my traditional one. Now, my new one, it looks like the period is going to be shifted. So if I, my general like heuristics, if you're not sure about what that word means, heuristic is kind of like a mental shortcut or like a rule. My kind of rule that I have in my mind is when you have a factor in front. You have like the cosine of 2 times x. The numbers above 1 will compress the graph horizontally. So if I put in cosine of 2x, I kind of squish it down. Like if you imagine it's a slinky, you kind of compress the slinky. So this is, if I was making up vocabulary, I might call this a compression factor. It's a factor in front of x that tells you how much you're compressing it by. Now, if we have 3/2, that's 1.5. We are compressing it by a factor of 1.5. So the way that I would think about that is that, like, for example, my full cycle went to 2 pi. Well, if I'm compressing it by a factor of 1.5 by 3/2, I think I should divide by 3 and then multiply by 2. I think that's what I would do. Um, what's a different way to say this? Actually, let me say this slightly differently. A way that I often approach these problems for figuring out how the period shift works. I know that the full cycle is complete at 2 pi. So if I have cosine of 2 pi or sine of 2 pi, I know that my cycle will be complete because I've traveled all the way around my unit circle. I've done my full 360 degrees rotation. So if I can get this equation to say cosine of 2 pi, then I should know where I'm going to be. I'm going to be done with my full cycle. So in this case, we have 3 over 2x. So if I want this whole thing in the inside to be 2 pi, well then x needs to be, what would it be? 4 pi over 3. If x was 4 pi over 3, then the 3's cancel out here. The 4 divided by 2 makes this 2 pi, and we have the 2 pi that we want on the inside there. So we will have accomplished our full cycle. We would have got 2 pi on the inside of that parentheses when x is at 4 pi over 3. So 4/3 pi. So if I go to pi and I think a third is like 2 boxes over, then I want to do 4/3. I want to go 2, 4, 6, 8. Okay, so I believe this is going to be my new point at which the cycle ends. So I can kind of erase that other one. Now this one should just be in the middle, so if I'm over by 8 right now, I guess I should just go over about 4 and come down. At that point, as long as we kind of connect them in a straight line, we will be able to finish our graph. I'm saying connect in a straight line just because we know that we're going to land on 0 for these two x-intercepts here. So those are going to be right in between. And I think that's good for that one. So yeah, so that will come up, multiple times throughout these where we're trying to figure out how to get what's inside the parentheses to be 2 pi. That's usually the kind of quickest way to figure out how to plot out your period. So graph the trigonometric function. We are going to take 1/2 the sine of 3/4. 3/4 x. So same exact thing. I'm going to say, what does my x value need to be so that on the inside of this parentheses I get 2 pi? So I'm going to get rid of that 3, so I'll put it on the bottom of the fraction. I want to have a 2, so I'm going to have an 8 up here. So if x was 8 pi over 3, then I would get 2 pi when that all got simplified down. Okay, so we can go to the graph and look for that 8 pi over 3. So pi over 3 would be every 2 boxes. So that's 6 and that's 8, I believe. 8 pi over 3, yes. Okay, so that's going to be the end of the cycle. We're going to get 2 pi in here. We're going to have our full rotation. We'll be done with our first cycle at that location of x, 8 pi over 3. We will only go up to 1/2 for our amplitude. And for the sine function, there'll be a point in the middle. We'll go up to 1/2. We'll go down to negative 1/2. Oops, something's off on there. Okay. So I want 2 pi in here. 8 pi over 4 gives me the 2 pi. Yes. Did I just get this part wrong? Okay, so that was pi. There are sixths right there, so that's 3/3. Oh, we wanted to go to 8/3. That was only 3/3. So that would be 6, and then 7, 8. Okay, I think this is the end of my cycle. I just miscounted on the graph. Let's try that out. Okay. Okay, the amplitude is always just the first number out front. Nothing more to it than that. The period, like I said, we're just looking for when is cosine of 2x going to be the same thing as um, cosine of 2 pi? Well, in this case, it would be very simple. It's when x equals pi. So our period will be complete when x equals pi. So along our x-axis at pi, we'll be done with our first cycle. Okay, write an equation of the form y equals a sine bx or cosine bx to describe this. So we'll go with cosine, because then we don't have to do any horizontal changes. We can see that the amplitude is 4 on there. We can see that the full period occurs at 8 pi. Okay, so if it occurs at 8 pi, that means it's been stretched out by like a factor of 4, right? Usually it would end at 2 pi. So if it's all the way at 8 pi, it's been stretched by a factor of 4, which would mean there should be like a 1/4 out front. This should fit the pattern that if I put in 8 pi in here, 8 pi divided by 4 would be 2 pi. 2 pi ends the cycle. Yep, so that checks out. And I think that would be all there is on that one. Oh, that is not. They want y equals. Now, one of the cool things that you guys are not going to see this year, because we're kind of wrapping this topic up, but you would see when you're looking at, more advanced classes that include trigonometry in it, um, is what happens when you add together waves. So if I have like the sine of x plus the sine of x, well, in this case, every position is just doubled. But if my other one was not the same frequency, you get these interesting situations where you can add together um, a wave that has like a really long wavelength to a wave that has a really short wavelength. So by itself, sine of 10x would look like this. So if you're going to add this to the graph of sine, well, you're going to take this blue line and sometimes you're going to add to it, and sometimes you're going to subtract from it, and sometimes you're going to add to it, sometimes you're going to subtract. And what you'll get is kind of a combination of those two ideas. And there are just kind of like any complicated waveform that you see, like when if we were to have a readout that was showing my vocal patterns, like that go up and down as the microphone's picking them up, there are techniques to disassemble those things into just a series of sine waves. That's what it is. So, like mathematically, to describe accurately what's going on with anything in the subject of like vibrations, this is the math subject that will get you there, is trigonometry. So anyways, it's just kind of like a application of like what is some of the broader ideas here. That's some of it. Okay, so here we have a prompt that says an object moves in simple harmonic motion with a period 7 minutes and an amplitude of 15. So, sorry. So amplitude of 15, it says it has at time 0, its displacement is at negative 15. So we are talking about something that is starting out down here at negative 15 and then oscillating. So I would do that as a cosine. I would say your amplitude is negative 15 to start down below, and I would do cosine of, well, we just need to figure out what the period is going to be. So let's see. We want the, let's see, starts at negative 15 and initially moves in the positive direction. Okay. Well, so if it starts at negative 15, has an amplitude of 15, I think this should be fine. The period of 7 minutes means that when we have the cosine of 7 times something here, we are going to finish off our first period, our first kind of rotation through the cycle. So we want 7x to be the same thing as 2 pi, right? Because 2 pi is the amount on the inside here that ends that cycle. So if we want that to be the case, x is going to have to be 2 pi over 7, right? Just to get rid of the 7 and put a 2 pi in there. So when x is 2 pi over 7, we have completed a full period. I don't think it's asking me for the period, though, is it? There we go. Okay, so we typically have our period at 2 pi, but we want that moved over to 7. So we want 2 pi to equal 7, just what we said before. Or sorry, we want, what am I trying to say here? Why am I confusing myself? Sorry guys, I'm struggling on this one suddenly. So we want this to get moved over to 7. Does anyone have a suggestion they want to put in the chat to bail me out? I'm having such a hard time with that. Okay, sorry about that, guys. So that makes sense. That follows the pattern that I was describing before, where we wanted a situation where if I put in a 7 for x, if I put in 7, whatever it was, minutes, then what I would have got out was that my period had been finished. So all I needed was 2 pi over 7, so that when x is 7, they cancel it out. All right. I think that'd be all there would be there. Okay, so in this one we've got one that says a person sitting on a Ferris wheel rises and falls as the wheel turns. Suppose that the person's height above ground is described by the following function: 21.3 minus 18.7 sine of 1.2 t. In this equation, h of t, the function is the height above the ground in meters, and t is the time in minutes. So we want the minimum height above the ground. Well, we start at 21.3, and at minimum we can go down by 18.7. So the difference between those numbers would be like 2.6, I think. The period is going to be, hopefully I don't have to go so slow this time through it. Got sine of 1.2t. So we want 1.2t to be the same thing as 2 pi. So we will divide by 1.2, and that is what we need to do. So 2 pi over 1.2, and they want that rounded. .24. Okay, so if it is 5.24, seems kind of like a long time, but that's what it is. Okay, so 5.24, so they're saying number of revolutions per minute. So if it takes you 5.24 minutes, and they want to know how many you do per minute, well, you're going to have less than 1, right? Because it takes you 5 minutes to do 1, so per minute, you shouldn't have a full 1. So we're going to do 1 divided by 5.24. We get 0.19, 0.19. If it helps at all and you want to kind of keep track of the units, this might confuse more than help actually. We were saying how many we wanted in 1 minute, and the 5.24, the units on that was 5.24 minutes per rotation, I believe. So if you're paying attention to the units, minutes are going to cancel out, and since you're dividing by a fraction, rotations are going to be up top. So what this is going to be telling you is, how many rotations you're going to be doing. You're going to be doing 0.19 per minute. Okay, so that was it for the first one. The second homework set is not too dissimilar. It just introduces doing some shifting around on the graph. We'll get to that in a few minutes. We'll take a short break here, at least long enough to let this video finish so I can start the next one. So let's take let's say a 10-minute break. This video was loading pretty slow last time with my other class, so we'll come back at 10:40 and take a look at our final assignment for this course.